Welcome to Penultimate Touch. Look at the first one. If a train runs at 60 km per hour, it reaches its destination late by 15 minutes. But if it runs at 80 km per hour, it is late by 7 minutes only. The correct time for the train to complete its journey. So I'll solve it. What we have discussed, that in this kind of questions, distance is equals to S1 into S2 into difference of time divided by difference of speed, right? So in this question it is 60 into 80. What is the difference of time? Difference of time is 8 minutes. So we have to, what is, why 8 minutes? Because late in both cases, so it will be subtracted. 15 minus 7 is equals to 8. This is in minute, but other data are in km per hour, so hour, so it will be 8 upon 60 hour. So there will be 60 here, and what is that difference of the speed? Is 20 km, so it will be 4, 60 gone, so 32 km is the answer. But in the first case, we have taken the speed where they have got late, the train has got late, right? So what is the right time? Right time is equals to, we are taking the first option, so it will be 32 upon 60 minus 15 upon 60, so it will be 17 upon 60. It's in hour. The answers are in minute, so 17 upon 60 means 17 minutes. 17 upon 60 hour means 17 minutes. I hope it is clear to you. If you have any doubt, you should comment. Moving to the next one. Next, A goes to a mall from his house on a cycle at 8 km per hour and comes back to his house on a cycle at 6 km per hour. If he takes 1 hour 10 minutes in all, what is the distance between his house and the mall? So how will you solve it? Earlier we have seen distance is equals to S1 into S2 into difference of time divided by difference of speed. When is it applicable? It is applicable in this kind of questions where there are two speeds and one is getting late or early and other is getting late or early. So there are difference of times. But when there is a total time is given, if it takes 1 hour 10 minutes in all, here it is total time, because so that these kind of equations, this kind of questions will follow this equation where S1 into S2 into total time upon total speed. Clear? When is this followed? When there is a total time is given and there are two speeds and the distance is equal in both the cases. Here the boy or the boy or A is a person, so this person is going to his house, going from his house to the mall and coming back from the coming back to the house. So the distance is not changing. So here speed 1 and speed 2 is 8 km per hour and 6 km per hour. What is the total time? 1 hour 10 minutes. What does 1 hour 10 minutes resemble? 1 hour 10 minutes. 1 hour 10 minutes means 1 and 10 by 60. So it's 7 by 6, right? So there will be 7 and 6 in the denominator. And what is the total speed? 8 and 6, 14. So 6 gone, 7 2, 2 8 4. So 4 km is the answer. 4 km is the answer. Clear? So 4 km is the answer. Option B is the right answer. Okay. I hope it is clear to you. If you have any doubt, you should ask. Moving to the next one. Next, A and B at a distance of 1.7 km apart, and they start running towards each other at a speed of 8 meter per second and 9 meter per second respectively. After how much time will they meet each other? So how will you solve it? It's a question of relative speed. What do we know? That relative speed is of two kinds. What are they? First case, they are moving towards each other, and second case is they are moving towards the same direction. Clear? In this case, number 1 is applicable because running towards each other is mentioned there. So what would be the relative speed? 8 plus 9 meter per second means 17 meter per second is the relative speed. And what do we know? Distance is equals to speed into time. In this case, it is relative speed. So it will be, what do we know? 1.7 km is equals to 1700 meter, because speed Speeds are given in meter per second, so it should be in meter, and also the answer is in minute, so we don't need the hour. Don't need to convert the speeds in hour. Okay, so relative speed is 17. We don't know the time, and distance is here 1700 meters. So this is equals to 1700, right? So 17t. So t is 100 minute. What does 100 minute mean? 100 minute resemble 1 minute 40 seconds. It is 60 minute 40 second. Clear? So I hope this is clear too. Moving to the next one. A part of the journey is covered in 31.5 minutes at 80 km per hour, and the remaining part is 16 minutes at 75 km per hour. The total distance of the journey is. So how will you solve it? This is a simple question. Distance is equals to speed into time. Here the speed into time is divided into two parts. One is 31.5 minutes at 80 km per hour, and the second part is 16 minutes at 75 km per hour. So the first one is 31.5. It will be divided by 60 because other data are given in km, and the answer is also in km. 31.5 by 60 into 80 plus 16 by 60 into 75. So it's 5, it's 4, it's 4. This is gone. This is 4, this is 3, this is 10.5. Right? So this is 20 and this is 42. Total will be 62. I hope it's clear to you. It's a simple question. 42 plus 20. If it's 42 plus 20. Clear? So moving to the next one. A person has to travel a distance of 30 km. He finds that he has covered 5/6 of okay 5/6 of the distance in 3 hours and 20 minutes. What is his speed in km per hour? So what's the total distance? Total distance is 30 km, and he has covered 5/6 of it. 5/6 of 30 km is 25. 6 5s are so 5 25 km. Clear? So it says he covered this distance in 3 hours and 20 minutes. What is his speed? So it will be 25 upon 3 hours 20 minutes. 3 hours 20 minutes mean 3 hours 20 minutes mean 3 and 20 by 6, 1 by 3. So 10 by 3. So it will be 3 by 10, right? 5 2s are 5 5s are 15 by 2 means 7.5. 7.5 is the speed, right? I hope this is clear too. It is an easy one. Moving to the next one. Next is the speed of a car increases by 2 km after every 1 hour. If the distance traveled in the first 1 hour was 35 km, what was or is? It should be is. Okay, is the total distance traveled in 12 hours. How will you solve it? This kind of problems can be solved in several ways, like taking x and all by using concepts. But I think the shortest and the easiest method is to follow this formula. D is equals to n by 2 into third bracket 2a plus n minus 1 into d. Fine. Here n is the total time. A is the distance covered in first hour, and D, this D means D is the increasing speed. Sometime it gives with decreasing speed, then it would be decreasing speed. Okay, so here n equals to total time. Total time means 12 hours, so 12 by 2. 2a is 35, 2 into 35 plus n minus 1 means 12 minus 1 11, and d, this d is equals to 2, right? So it will be 670 plus 11 into 2 means 22. So 6 into 92 is the answer. It will be 552. 552 km is the distance. I hope it is clear too. If you have any doubt regarding this question, you should ask. Okay? Keep this formula in mind. There is nothing difficult to remember, but this is the simplest and the shortest way to solve it. It can be solved in 2 lines. I have written this formula for your reference. Otherwise, you just start it from here, and you will in the next line it will be here 6 into 70 plus 22, and you don't even write to this line. You can straight write this 6 into 92, and 552 will be the answer. I hope this is clear to you. If you have any doubt, you should ask. Okay, I'm moving to the next one now. A takes 2 hours 30 minutes more than B to walk 40 km. If A doubles his speed, then he can make it in 1 hour less than B. What is the time taken by A to walk a distance of 40 km? So how will we solve it? Look, what do we know? That speed is inversely proportional to time. In this case, A's speed in its first case, its second case. Okay? It was if it says A doubles his speed, right? So if in first case if A's speed was 1, in second case it's 2. It's in a ratio of 1:2, and A's time will take in then 2:1 ratio. What's the difference? The difference is 1. But in this case, in the question it says in first case A takes 2 hours 30 minutes more than B. But in the second case it says he takes 1 hour less than B. So if we take B as the middle point, in the first case it was taking 1 hour 30 minutes means 2 hours 30 minutes means 2.5 hours more. But now it is taking 1 hour less. So it will be summed up. So what is the difference of time? Difference of time is 3.5. So 1 is equivalent to 3.5. The question is, what is the time taken by A to walk this 40 km distance? So this is taking 2. This is taking 2 unit. So 1 is equals to 3.5. So 2 will be taking 7 unit, means 7 hour. Right? 1 is equals to 3.5 hour. So 2 will be equals to 7 hour. I hope it is clear to you. It is the shortest process to solve this question. Otherwise, you can assume you can do it by doing 40 upon A plus 40 upon B, not plus but minus. It will be 2 hours 30 minutes and all. It will take a lot of time. So this is the simplest way to solve it. I hope it is clear to you. If you have any doubt, you should ask. Moving to the next one. Next, a car covers 25 km at a uniform speed. If the speed had been 8 km more, it would have been taken 10 hours less for the same journey. What is the speed of the car? What we have discussed? What formula do we use here? First, try to recall that. Will it be D equals to S1 S2 into total time by total distance? Total speed, or S1 S2 into difference of time by difference of speed? I think the latter one. S1 into S2 into difference of speed and divided by difference of speed. How will you solve it? S1 S2 is nothing is given, just S1 into S1 plus 8 km more, its sides 8 km per hour more. What is the difference of time? Difference of time 10 hours less, so it will be 10, right? And this is the difference of speed. Difference of speed is 8 because 8 hour more. This distance is given here. What is the distance? It's 25. It will be equal to 25, right? So how will you solve it? It will be 10, 5 to the 5, 5 the 2, 4 the. So S1 into S1 plus 8 is equals to 20. So it can be written like this: S1 plus 8, 2 into 10. So if this S is equals to, then S is equals to 2 and S1 plus 8 equals to 10, right? So 2 km. What is the speed of the car? It is 2 km per hour. I hope it is clear to you. Option D. It is option C. Point C is 3. Option B is 4. I hope it is understandable to you. Then S1 is equals to 2 km per hour. You have to solve this equation like this, otherwise you have to solve it in quadratic equation. This is the easiest process. Just break down the number. Okay? If you have any doubt regarding this question, you should comment. Moving to the next one. Number 29 says the ratio between the speeds of two trains is 2:5. The first train covers 250 km in 5 hours. Then the difference between the speeds of both the trains is. The simple one. Nothing is there. Okay? What do we know? Speed. Oh, we don't require that too. Speed is inverse proportional to time. We don't require this too. Speed 1, speed 2. 2:5. Fast train speed is 250 km in 5 hours. So speed is 50 kmph. So this 2 is equivalent to 50, right? So it is 25x. So it will be also 25x. So it will be 125. The question is the difference between the speeds. So 125 minus 50 is equals to 75 is the answer. Right? I hope it is clear to you. If you have any doubt regarding this question, then you can still ask. It is the simplest question I have ever discussed. Move on to the next one. Number 30. Richard travels from A to B at a speed of 15 km per hour, from B to C at 20 km per hour, and C to D at 30 km per hour. If AB is equals to BC is equals to CD, then find it's the Richard's, this will be apostrophe S, Richard's average speed. I hope it is understandable to you. I am reading it again. What said that A to B, if this is AB, then AB is covering at 15 km per hour. B to C at 20 km per hour. And C to D at 30 km per hour. But what said that AB is equals to BC is equals to CD. So when the distance is equal, the LCM of the three speeds can be the total distance. We can assume it like this. Let it be 60. This is LCM. In time and work, how we used to get the total capacity or assume the total capacity or total work. Total capacity in pipe and station and total work in time and work, right? We used to do the LCM of the given works, means solving days and all, but and get the efficiency then. So in this case, LCM is equals to total distance. We are just letting it assume total distance, right? I hope it is clear to you. So in that way, it says that in the question, then find Richard's average speed. How to get the average speed? We have already discussed how we calculate average speed. Average speed is equals to total distance upon total time, right? So total distance in this case is 60 plus, it is 60, it is also 60, it is also 60, right? So it is 60 into 3. Clear? What's the total time then? Total time is 60 upon 15 plus 60 upon 20 plus 60 upon 30. So this means 60 into 3 means 180. 180. Clear? 15 4s are 60, 23s are 60, 32s are 60. So it will be 180 upon 9. So 20 km per hour will be the average speed. I hope it is clear to you. If you have any doubt regarding this question or any question which we have discussed in this video, you should comment, okay? Thank you.